Imagine two corporations tackling the same workload. One hires a handful of elite specialists. The other builds a huge team of simple workers. Which approach wins? On the left, we have CPU Corporation, a company built on high-skill, high-precision experts. On the right, GPU Corporation takes a very different strategy to solve the same problem. CPU Corporation employs 8 highly trained engineers, each equipped with advanced tools, large workspaces, and extensive expertise. These engineers are top-tier professionals with deep knowledge and versatility. They're costly because they're exceptionally capable. Now look at GPU Corporation. Instead of a few elite engineers, they hire over 1,000 entry-level workers. It's the difference between a special ops team and an entire regiment. These workers earn far less, not because they're inefficient, but because they're optimized for a narrow. Now the real test begins. Both companies receive the exact same assignment, and the outcome is revealing. The task: process 1 million identical forms. Same data, same calculation, repeated a million times. CPU Corporation's 8 experts work flawlessly, but they can only process 8 forms at a time. GPU Corporation, however, processes 1,000 simultaneously. The result? GPU Corporation completes the job dramatically faster, not because their workers are smarter, but because the task perfectly matches their strengths. That's the core difference between CPUs and GPUs. For parallel repetitive workloads like graphics rendering, neural network training, and scientific computation, the GPU's massive workforce excels. It's not about brilliance. It's about aligning the right workforce with the right kind of work.